And number 35, the volume of a large can of tuna fish is given by this formula for volume, which is basically the volume of a cylinder. Coming down here, when it says define the radius r in terms of the other ones, that means you want to solve for r. So what I'm going to do is I'm going to rewrite it like this. This is basically the commutative property of multiplication. Okay, so what I'm going to do is divide both sides by pi h. Now what I'm going to do is square root. So the radius is the square root of the volume of pi h. Determine the diameter to the nearest inch of a large can of tuna fish that has a volume of 66 cubic inches and a height of 3.3 inches. So now what I'm going to do is plug in all that relevant information. The volume is 66. The height is 3.3. Now, when you're putting this in your calculator, if you do not group the pi times 3.3 as a denominator together with the parentheses, you will get a different answer. Now, this means my radius is 2.523. Now, this is where it's tricky because the diameter is double that. So if we double the radius, we get 5.04. So to the nearest inch, the diameter is 5 inches. And number 36, we have to state the linear regression of this attendance at a museum. They want 2007 to be represented by 0. Now, if you notice, we go 2007, 8, 9, 11, and 13. So if this is 0, 1, 2, 2011, well, 2010 skipped, so I skipped 3, I call this 4. 2012 is skipped, so I call that 6. So in your lists, I get there by going to Stat and hitting Enter on Edit. So in my list 1, I'm going to hit 0, 1, 2, 4, and 6. In my list 2, 8.3, 8.5, 8.5, 8.8, and 9.3. They want you to find the linear regression equation, so I'm going to go back to Stat, over to Calc, down to linear regression. I hit Enter. I want to take the y equals ax plus b, and I want to round the nearest hundredth. So I should have y equals 0.16x plus 8.27. This would give you full credit. This problem is strictly for the calculator. Now state the correlation coefficient to the nearest hundredth and determine whether it's a strong or weak. The correlation coefficient is the r. So I'm going to state the correlation coefficient to the nearest hundredth. That's 0.97. Determine whether it's a strong or weak correlation. It's strong since the value is very close to positive 1. And number 37, we talk about this rectangular picture. The picture is 6 by 8 inches, and then we're going to put a frame around it that all has the same width. So if we call that width x, what we're going to say is that, well, he wants this max width of the frame. He wants it to be the maximum area of the frame picture to be 100 square inches. So the area is going to be length times width. The area is 100. He wants it to be, this length times width has to be, no more than, so in this case, it's got to be, this has got to be the maximum, so we use greater than or equal to. The length is 8 plus 2x, and the width is 6 plus 2x. You could also have them backwards and say, explain how your equation models the situation. The area cannot be more than 100 square inches, which is why we use that inequality. And we added 2x to both since the frame is the same width all the way around. Solve the equation to determine the width of the pieces of wood used for the frame. So what I do is I take that inequality, I FOIL, I expand, and then I basically, bring this 100 over because I want it to be equal to 0, or excuse me, in this case, less than or equal to 0. So what I'm going to do is write it in a form that I'm more comfortable with. And then say A is 4, B is 28, and C is negative 52. And then I'm going to use the quadratic formula. Plugging in all of these A's, B's, and C's into the quadratic formula, I get such. Putting into my calculator, I either get 1.52 or negative. Can't have negative in terms of measurements. They want it to the nearest inch, so it looks like it has to be at the maximum of 1.5 inches.